Assalamu alaikum. This class will be about differential calculus. Differential calculus is the branch of mathematics which is used to find the gradient on a curved graph. Here we are not going to discuss details of the rules of differentiation, etc. We are only going to discuss the relevant portion of calculus, the differential calculus, to find derivatives, which is to find the slope on a curved graph, and which is related to IGCSE, AQA syllabus, mathematics, and somewhat with AdMaths of O level, CIE, and somewhat with A level. Now let's say we have a graph like this, and we have to find a gradient. It's a straight line graph. What we'll do is select 2 points on the graph further away from each other, and we'll see the x and y coordinates. And then we might put the formula m, which denotes the gradient. M is equal to change in y value over change in x. The delta, the triangle, refers to the change. So let's say the value here is 4, 8. The value here is 0, 2. So the y values were 8 and 2. So top value minus lower value of y is 8 minus 2 over the x value was 4 and lower one is 0. So 4 minus 0, what do we get? 8 minus 2 is a 6, and 4 minus 0 is 4. So 6 over 4 gives us 3 over 2, which is 1.5. So here we can easily find that the gradient is 1.5. This method is also similar to the one drawing a triangle, horizontal line from the lower point, vertical line from the upper point, joining them to make a triangle with the graph, and using this line as rise, like change in y, and using this horizontal line as change in x. So it's easy to find gradient of the graph if the graph is a straight line graph. Now what if we have a curved graph? Let's say a graph like this, curve. This is the equation of this graph, can be y is equal to x squared. Now let's say this is the point on the graph at which we have to find the slope, the gradient. Now what we have to do is draw a tangent to the curve on this point, and tangent, if you don't know, to the curve is a line to the circle or the curve that touches the edge of the circle or the curve, but it doesn't like cut through. It only touches the edge, like the floor is to the wheel. So what we'll do is we'll draw a straight tangent it's not almost perfectly drawn, but roughly straight line, and then we'll use this tangent to use 2 points on this tangent and use the rise over run method to find the gradient. Change in y, change in x, and m denote the gradient. M is equal to change in y or change in x values. Now the problem which will arise here is that the slope, the tangent to the curve, will not be exactly the same for each and every student. Some of us will draw like this, others will draw like this, and it will seem like we are crossing the same point, and you can see the slope is very different, and obviously different slope will give us different values of the gradient. Like a steeper slope will give us higher value, as if which you can imagine like the steeper the slope of a mountain, the higher, like the faster the speed will be of the rolling ball downwards, and the less steep it is, ball won't roll as fast. So the gradient can be somewhat proportional to this ball. Now, to find the exact value, the exact uh, value of the gradient to the graph, we have differential calculus, and there is a thing called derivative. Derivative means a derived formula, like a derived gradient from the slope. It's simply the slope derived, the equation of the slope of the gradient derived from the equation of the graph, of a curve graph. And the simple formula is, just look at the equation of the graph and see the variable. Here the variable is x. You have to look at the coefficient of the variable and the power of the variable. What you will have to do is, to find the derivative is usually like, to find the derivative of this graph, you'll have to do this, to write this derivative of x squared, which is the equation of this graph, over dx. Now, what you have to do is simply make the power, like multiply the power with the coefficient. Here we don't have any coefficient of x squared, so that means it's simply 1. So to find the derivative, we'll multiply this 2 with the coefficient over here, which is 1, so 2 ones are 2. Here we get 2, and the coefficient, the variable will remain the same, and the power will be reduced by 1. So 2 minus 1 is 1, and therefore it's simply 2x. And that's very simple. That's the simple way. The power will become the coefficient, like the power will be multiplied with the coefficient and will be reduced by 1, and that will be the derivative. Now there are certain more rules as well. We are not going to discuss those because those are for university level or A level, etc. Here we are only discussing the differential calculus, which is concerned with IGCSE level. Now here we get the simple formula for the gradient. Let's say, now we can use this simple formula. Let's say we have to find the gradient on this point, of this point. Now we don't need to draw any tangent to the curve, etc. What we have to do is see what value of x is here. Let's say here the coordinate is 2, 4, for example. So x value over here is 2. We simply put the x over here, so it's 2 times 2, and that becomes 4. So using the differential equation, we find the equation for the gradient and put in the values of x of the point we want the gradient of, and then we find the gradient. So using that example, we can see if the equation is y is equal to a number times x with a certain power, the equation for the derivative will be, the derivative of this equation will be the power multiplied with the coefficient, and the coefficient's power after multiplying with the variable's power after multiplying with its coefficient will reduce by 1. And that's the simple way to find the derivative. Okay, now we will use some examples. Let's say we have a graph, a horizontal graph. This point is 3, and the line that cuts y-axis at a certain point will be called y is equal to that point. So here it cuts straight y-axis at 3, so this line is y is equal to 3. So as we know, the straight line graph equation is usually in this form: y is equal to mx plus c. C is the y-intercept where the y-axis is being cut by the graph, and m is the gradient of the slope, and x will be there to show like to for the function of the graph. Now we can see here there is no x mx over here, no number multiplied by x, because the gradient is 0. So the simple rule to see whether the gradient is 0 or not is that any line which exactly horizontally cuts y-axis, the gradient is 0. And we can also use this derivative to prove this as well. For example, this line is y is equal to 3, and please know that any number raised to power 0 is equal to 1. Now y is equal to 3 can also be written like 3x raised to power 0, because 3 times 1 is also 3, is the same thing. So if this is the equation, y is equal to 3 can also be like y is equal to 3x. So the main equation of this graph can also be written y is equal to 3x raised to power 0. What should be the derivative? Difference in y, sorry, the dy dx. This will be, as we know, the power will become will be multiplied by the coefficient, and the variable, the x, the power will be reduced by 1. Now as you know, 0 is being multiplied by all the numbers, so the answer is simply 0. And therefore you have also proven using derivative that the gradient of a straight, like exactly horizontal line graph is 0. Now we'll use further examples to show the use of derivative. Let's say we have a graph of the equation y, or function of x, which can be used interchangeably, is equal to x cubed, and we need an equation to find the gradient on a certain point on the graph. We'll use the derivative again. So d of y for the is the power will become the coefficient, and the variable's power will be reduced by 1. So 3 as reduced by 1, it becomes 2. Thus we got the formula for derivative. So now we can use this to find the gradient. You will have simple questions like find the derivatives of these equations, y is equal to 2x or y is equal to 3x squared. Again, you know, here when there's no power written, the power is 1, so 1. So derivative of this equation will be 1 times 2 variables power reduces by 1, which is 2, and x raised to the power 0, 1 minus 1, and any number raised to the power 0 is 1. So 2 ones are 2. So the gradient of this graph will be 2. And to differentiate this, finding the derivative is differentiation, and to differentiate this equation, again we use the same method. The power becomes the multiplies with the coefficient 3, so 3 times 2 is 6, and the variable's power reduces by 1, so 2 minus 1 is 1, so it's raised by 1, and there is no need to write the power of 1. Simply 6x is the derivative of y is equal to 3x squared. Now another question, like some different types of questions will come here, like let's say the graph is y is equal to x cube and you have to find the gradient at the point which is the coordinate of which is 2 8. So obviously we have to do with the x value, the x coordinate. Again, the first step is to find the derivative of this equation. So the power becomes the coefficient and power reduces by one of the variable, so 3x2. So 3x2 is the derivative. Now here x value of the coordinate will be put in its place. So what do we get? 3 times, and x is replaced by 2 because we are finding the the gradient of this slope which cuts this point. So 3 raised to power 2 is 3 times 2 to the power 2 is 4 and 3 4 are 12. So 12 is the gradient of the slope of the tangent to the curve at point 2 8. Now if you have a tougher example like 9x squared plus 6x plus 1 and you have to find the differential, so even then it's no problem, you just have to do the same step with each term which is being added or subtracted. This here there is no x, so we can put x raised to power 0, which means the same thing times 1, because any number raised to power 0 is 1. Here we can put 1 as power because there's no power written. So first we'll do this. So 2 will be multiplied by its coefficient, so 9 2s are 18, and x, the variable, its power reduced by 1 to 2 minus 1. What is it? 1. So 1 there's no need to put 1 here. Now here plus, now this term, so 1 is the power, will multiply by the coefficient 6, and the power will reduce by 1. 1 minus 1 is 0. X raised to power 0, it is 1. And here we have 0, so the power is 0, and therefore 0 will multiply by the coefficient and the power will reduce by 1. 0 minus 1 is 1. Now this is the equation. 18x plus 6 times 1 is 6 plus 0 times anything is 0, so there's no need to add that. So it is 18x plus 6. Now we have found the equation of the gradient, which is 18x plus 6. Now let's say the question says that find the equation, find the gradient of this graph at point x is equal to 3. So simply what you'll do is replace this x with 3, so it will become the gradient equal to 18 times 3 plus 6, which is equal to 54 plus 6, which is equal to 60. So the gradient is 60 at point x is equal to 3 for the graph 9x squared plus 6x plus 1. Now we are done with most of the important things in this chapter, but let's say we'll have to find the equation of the tangent as well for the curve we are drawing. Then what we'll have to do, as we know that, let's use this very example again. So we already found the equation of the tangent and also the gradient of the tangent and also the gradient itself. Now let's say we know that the tangent will be a straight line on a graph. On a graph, the curve, the tangent will be a straight line. And for the equation of a straight line, we know that it is always something like y is equal to x plus c, where m is the gradient and c is the y-intercept. That means the point on y-axis at which the line cuts. For example, this green line is cut in y-axis at point 4, then here c y-intercept will be 4. And one important thing about this line is that any point which you select on this line, the value for x is obviously 0, because let's say these are values for x. X is 4, 3, 2, 1, 0. So any point over here, only y values will increase, the x values will be 0. So if this point is 4, the coordinate of this point will be 0, 4. Now let's use the equation example you already have done. Let's put this in this equation: y is equal to mx plus c. The equation of a straight line graph will always be something like y is equal to mx plus c. Now we have to find m and we have to find c. We already found the m, which is 60. And x, so the equation should be something like 60x plus c. Now we'll choose a certain coordinate on this same graph, where we will get one value for y and one value for x, one value for x. Here now x is equal to 3. Let's say for this line, for the tangent, we select a point x is equal to 3 and sorry, the point is 3 and 100, like y is equal to 100. So in the place of y, let's put in the value for y, which is 100. So 100 is equal to 60, and x value will be put here, which is what was it, 3, and c will be remaining variable, and then 100 is equal to 60 times 3, we get 180 plus c, and then what do we get? 100 minus 180, when 180 goes to the left, is equal to c, which is equal to minus 80. So c is y-intercept, which is minus 80. That means y-axis is cut in minus 80. So now we get the equation. So the equation in the form of y is equal to mx plus c is found. So the equation should, for the tangent, should be y is equal to m was found to be 60. X should be remain like x should be remaining like that, and c is now found to be minus 80. So the equation is y is equal to 60x minus 80. And that's how to find the equation of the tangent to the curve. Now let us have another example of a finding the gradient. Okay, so the question is y is equal to x raised to power 3, and let me write it down quickly. Y is equal to x to the power of 3 minus 3x to the power of 2 plus 2. So here we have to find the equation of the tangent to the curve again, using this formula. This is the equation, and first we need to have both coordinates x and coordinate y. So we know that the point x is 3. What about y? We'll use the same equation to find that. So let's put x values in it. So to find point y, coordinate y. So x cube, we put 3 over here. 3 raised to power 3 minus 3 times 3 raised to power 2 plus 2. This will be the value of y according to this equation when x is equal to 3. Let's do it. So it is 3 the 9 and 3 the 27, so 27 minus 3 is to again 27, 27 minus 27, they both cancel each other out and we are left with plus 2, so y should be plus 2. So there we got the value of y to be plus 2, simply 2. Now first we have to find a differential, and then we'll find the equation, and then put in the values to find the y-intercept and find the final thingy. So this is the main graph equation. So using differential method, we'll find the equation for its a what do you call it, the gradient, equation for the gradient. So again, the power will become the coefficient of x, and power reduced by 1, it becomes 2. The next term now, the power is 2 and it becomes it multiplies with the coefficient 2 3 to 6, this and this, 2 3 to 6, and x now power will be reducing by 1 1. Now here we have no x, so let's put it here, and to the raised to power 0, to the power 0, because anything raised to power 0 is 1 and 2 times 1 is 2, so it's the same thing. So for that, what we'll do, the power will be multiplying by the coefficient of 0 of x, sorry, and x power will reduce by 1, so 0 minus 1 is minus 1, and therefore 3x squared minus 6x plus 0 times anything is 0, so plus nothing. So this is that we done with the equation of gradient. Now let's put in the x to find the gradient. X is 3, so the gradient should be 3 times 3 square minus 3 times 3, sorry, 6 times 3. Now therefore gradient is equal to 3 to the 9, 3 to the 27 minus 6 to the 18, which is equal to 9. So the gradient is 9. Now again, we know that the equation of the straight line graph, the tangent in this case, should be y is equal to mx plus c. So since we have found the m over here, so we'll replace this with 9, which we have already found. So let's put 9 over here because we found it to be 9. Y is equal to 9x plus c. This is the equation of the tangent. Now only c is to be found. So back there we have the values that y is 2 when x is 3, and we'll use these values. Y is 2 when x is 3 to find y-intercept, which is c. So 2 is equal to 9 times 3 plus c, and we get 2 is equal to, consider 27 plus c, and therefore 27 goes to the left side and becomes minus, so this becomes minus 25 is equal to c. Therefore the equation should be y is equal to 9x, and we have found c, which is minus 25. So let's put minus 25 rather than plus c. That's we done here. Y is equal to 9x minus 25. That's the equation of the tangent to the curve of the graph with this equation.